Hello, everyone. My name is Pornsook, Kornkitichai. I come from Thailand, and today I'm going to talk about how to defend PowerShell attacks when every defense fails. But before going further, I would like to introduce you a bit more about myself. I'm working as a senior manager and a lead of security assessment team at ASIN Fortech, Thailand. And basically, my everyday task is a lot about pen testing or doing some kind of IT security consulting. And my research interest is about offensive security, and sometimes it's about defensive security, about cyber warfare. Now, the topics that I'm going to cover for today, there are several ones. First one is about, I'm going to talk PowerShell and its offensive sides. Next is about why all defense against the PowerShell attack fails. Next, I'm going to talk how and why it is quite difficult to do some implementation to defend the PowerShell. And next, I'm going to introduce you the prototype of PowerShell to defend those attacks. And then I'm going to do some demonstration. Basically, if you have ever used PowerShell before, you might have the question, why there's PowerShell in the newer version of Windows? I'm going to talk about a little bit about PowerShell because when you're going to, in those days, in Windows, we have just only command. But sometimes later, developer in Microsoft would like to have some kind of powerful command line, like shell in Linux. But as you know, it's different platform. In Linux, it's file-based platform, but in Windows, it's API and object-based. So we cannot implement some kind of shell command look like the shell in Linux. So they create things like PowerShell and build other things, just cover it. But since 2010, there have been lots of several works and research related to offensive side of PowerShells. I'm quite certain that there are a lot of people here have ever seen this list of offensive PowerShell modules before, but I would like to give you a quick overview of each of modules. The first one is PowerSploit. PowerSploit is a collection of post-exploitation PowerShell modules. If you're a pen tester, you can use it to bypass antivirus, to invoke some shell code injection, or you can use it to do some data exfiltration. Another framework is Nishang. Nishang is a collection of PowerShell scripts and payloads. The main purpose of Nishang is just only offensive security. Next is View PowerView. If you have ever heard of View framework before, this module is the same author. The idea of PowerView is used when pen tester would like to attack some environment, but that environment disable net command. So the author of View PowerView creates some modules to mimic the behavioral net command. For example, you can use get net user or get net group instead of net user or net groups. Next is Power Up. One of the is one part of Power Tools. Power Up is used for local privilege escalation. And another framework is PowerCat. PowerCat is Netcat, but it's implemented in PowerShell. Next is the payload called Interactive PowerShell Payload in Metasploit. If you have ever used Metapreter before, if you run shell and then type PowerShell.exe, your session will be frozen because you cannot have an interactive session with the PowerShell. So in this day, there have been a payload called interactive PowerShell that you can use and get an interactive to the PowerShell on the target system that you attack. And the latest work is PowerShell Empire. It's published in besides Las Vegas this year. Basically, its idea is about create some kind of PowerShell engine, send it to the target system. When the target system runs the PowerShell agent, it connects back to your command and control. Then you can do anything you want with PowerShell. For example, you can send something like shellcode injection or do some DRM injection or do anything you want with PowerShell. It looks like Metasploit framework, but it's PowerShell. So these are just only some examples of offensive security modules of the PowerShell. Next, I'm going to talk about why all defense of PowerShell fails to prevent the attacks. The first one is, this is the first line of defense. Maybe you have heard of this before. It's an execution policy. If you are new to PowerShell, if you are an uninformed user, you cannot run PowerShell script. But if you are informed user, you can run PowerShell script. As you can see from the screenshot, you cannot run PowerShell script. The PowerShell script format is .ps1. One thing that you can do is just type the command on the console or just copy the PowerShell script and paste in the console and run it. That's the way you can do. And if you know about how execution policy work, you can bypass it. Normally, there are 5 options for execution policy. One is restricted, which is the default setting. Second is unsigned, all signed. The third one is remote signed. The fourth is bypass. And 5 is unrestricted. If you just change the option to bypass, you can do anything. Well, the main purpose of this execution policy is to prevent users from running the PowerShell script unintentionally. It is not designed to defend the attacks, so it's not the defense. Another technique to bypass execution policy is you can use base64 encoded commands. For example, if you have the PowerShell script, you just encode it to base64 and paste it into the PowerShell command console and run it. You can bypass. Another thing that I talk about encoded command because some antivirus, when you download, when you use some PowerShell script, when you attack the system, some antivirus can detect it. You can use encoded command to hide yourself. But there's a limitation in Windows XP and the newer version because the length of the console is limited to around 8,100 somethings. If you have a very long PowerShell script, you need to do some compression and then decompress it in the memory. Some people in Dark Operator write a module to do this for you, so that's not the problem. Another protection mechanism is App Blocker. App Blocker was introduced since Windows 7 and Windows 2008 R2, but you can use it only on the Enterprise and the Ultimate version only. The purpose of App Blocker is to allow administrators to lock down the system to prevent any running from the unauthorized applications. You might have heard about software restriction policy. It is the same, but it is the older technique, older system. Why is this older? Because when you set up software restriction policy rules, you cannot apply to each user or each group, and it's quite difficult to manage. But if you enable both app locker and software restriction policy at the same time, your machine will choose only app locker's rules. When you apply app locker to prevent PowerShell, you can use to block executable files or just PowerShell script file. Let's see. If you set the rule here with PowerShell.exe and ISE.exe restriction, you cannot run it. Next is you can use to prevent any running the PowerShell script files. But as you know, this is the setting from administrators. If the attacker can gain access to the previous accounts, previous level of the system, this protection mechanism is useless. Now moving to some kind of PowerShell remoting. PowerShell remoting means that if you run PowerShell and would like to execute on the remote machine, we call this PowerShell remoting. When you use PowerShell remoting, you connect to the default remote session configuration. You can find some configuration on your machine with this command, get peer session configuration. It will list all settings of the remote endpoint. But in newer version of PowerShell from PowerShell v3 and later version, you can enable some constrained PowerShell endpoint. What does it mean? It means that you can limit the number of the commands that the remote session can use. For example, I connect to the machine called Windows 81, Windows 8.1 something, and try to list the number of the command. What I got back is around less than 10 commands that I can use. Normally, there are more than hundreds of commands in PowerShell console. So if you want to apply this inside your enterprise, inside your organization, you could do it, but same as app locker, if attacker can gain access to the admin level, constrained PowerShell doesn't help. Next is about lockdown policy. PowerShell lockdown policy, there is not much information related to it. There's just two links. The thing is, you can use some environment variable by creating some variable with called PS lockdown policy and set the number to false. Your PowerShell console will change the mode into constrained language mode. What this means is you can use commandlet in PowerShell, but you cannot access any type of .NET object. You cannot access class. You cannot access instance because it is in the mode called constrained language mode. But the same assumption, the same thing. Attackers know about this very well. They can delete this variable and apply it. They can bypass this easily. So my work, what is my work about? My work is working based on this assumption. First, attacker could gain access to the previous account. For example, they can gain access to local administrator of the target system. They can gain access to one account of domain admin group. Second assumption is they can enable PowerShell remoting. And third, all of what I said before, all of the protection I mentioned earlier, attackers know it very well. And fourth, I don't talk about event logs because attacker can disable it. That's it. Next, why is defense against PowerShell attack is difficult. Some of you might think why we don't do some hooking or just intercept into Win32 API function. I did it, but it's quite difficult. Let's see the screenshot above. If you call local PowerShell, there will be a PowerShell.exe process spawn here. And then if you do some kind of stack tracing or monitoring the stack trace, here, you will see that there is no proper point to do some hooking or interception. All of what you can see is .NET. For people that is very new to PowerShell, PowerShell is implemented with all .NET objects, class and instance library. So there's no point to intercept Win32 API. For PowerShell remoting, you might think that why we don't do some kind of interception and analyze the traffic or malicious traffic. I did it the same. Basically, when we use PowerShell remoting, PowerShell used the protocol called WSMAN, Windows Web Service Management Protocol. It runs on HTTP and HTTPS on port 5965 to 66. Sorry, 5985 to 86. But when you use HTTP, the HTTP content is encrypted. You can see only the HTTP header, which is not much, give you much more information. You can see just only, it encrypts with something. When you use PowerShell remoting inside domain environment, it is encrypted with Kerberos. But if you use in the workgroup, it encrypted with CLED SSP. You cannot do any man in the middle. However, if you use HTTPS, all HTTP header and content are encrypted twice. So it's very difficult to do some man in the middle here and do some analysis on malicious traffic. But in this year, Microsoft published some tools, very nice tools. Basically, if you do some traffic or network sniffing, you use Wireshark or TCP dump. But Microsoft has a new tool called Microsoft Message Analyzer. You can watch some granular details of message in each event or each process that Windows uses. When I run Microsoft Message Analyzer, when I use PowerShell remoting, I can see everything. You just see here, everything is in SOAP message because PowerShell remoting uses web service. You can see some plain text message, plain text communication. You can analyze it. But it's impractical to apply this function into each and every workstation in the organization because it uses or utilizes a network resource and workstation resource too much. So this is why it's quite difficult. Last year, there's a paper, a well-known paper in the PowerShell community. It is investigating PowerShell attacks. Published in DEF CON 2014 and Black Hat the same year. The paper tried to find information about how to locate some evidence from memory and from event logs when there is a PowerShell attack. I will give you some recap before going further because it's very important to my work because this paper very influenced my platform as well. When you do some PowerShell remoting, when you type the command line on your PowerShell console, your command line inside your machine is a .NET class and object. It will serialize and then send it to the target system, the target workstation on WSMAN protocol. When that communication traffic received by the dispatcher on the target system, it will locate which application has been registered to the dispatcher. It will consider whether it is PowerShell or not. Whether if it is PowerShell, it will send it to wsmpropose.exe. This one. This is the target machine when it receives some remote PowerShell command. And if you spawn any other executable files, it will spawn another process. This paper said that if you want to see some PowerShell command, if you want to see some important remnant of the memory, you need to do some memory analysis against wsmpropose.exe. But the problem is WSMPropose terminates itself immediately after the end of the session. That's why it's very difficult to do some real-time analysis on the memory of the WSMPropose. So, from the assumption from the latest study, I'm going to propose the prototype called PowerShell. You can implement or you just copy my idea to apply it to some workstation in your organization or just apply it to some HoneyNet machine. The idea is divided into 3 components. The first one is C2, command and control. It will have like centralized log command, receive and send the command, receive the event from the agent or the sensor. Second is the client. I call it sensor. And from my experiment, I did it on Windows 7 and Windows 8.1 with Windows PowerShell v2, v3, and v4. Another internal component of the sensor, 3 components, 2 adapters and 1 sensor. First is PowerShell adapter, next is WSMPropose adapter, and then sensor. Sensor is run because it needs to communicate with the C2. You can see number 4 and number 5. Number 4 is command from the C2. Number 5 is the traffic or event information from the sensor. It is encrypted with AES encryption. So I'm going to solve the problem of WSMPropose.exe. You can see that this is in the part C Windows System 32. I will locate WSMPropose. Here, you might notice that there are 2 WSMPropose.exe. The real one, every machine since Windows 7, I rename it into WSMPropose1.exe. You can rename it into anything you want. You just change the configuration file in the prototype. And the fake one, I mean my adapter is WSMPropose.exe. So next time, if there is a PowerShell remodeling, it will go direct into your adapter. Some prerequisite is WSMPropose and PowerShell.exe. The owner of this application is not user, not general user, is trusted installer. If you rename it, you need to change the owner, and then after you rename it, you need to change it back. This is a prerequisite. Now, what I'm going to intercept is, I'm going to intercept some Windows 32 API to locate some important information. I try to intercept two processes in the initial state. The first one is exit process. As I mentioned, the problem is it terminates very quickly. You cannot do anything with itself. So I will hook in exit process because I need to pause some time and then do some memory analysis before it terminates itself. And then I hook with create process because I would like to know if attacker spawn some other executable files. And next is a ws232.dll. What I want to is to monitor some network traffic because malicious PowerShell modules often download things from the network. Okay, this is what I'm going to try to locate inside the memory. From the paper investigating PowerShell attack, they try to find, do some memory analysis and find the pattern of the command from number 2 to 5. But from my experiments, number 1 is very important too because it contains some previous command that attacker used. Okay, let's see some demonstration. I have 3 demonstrations. The 2 are video demonstration. The reason is because I need to change the, I need to turn on and turn off some PowerShell and OS. It needs to take some time, so I will show video demonstration for 2 and live for 1. Okay. The first demonstration is series of remote PowerShell command. For Windows 7 is the client. Yeah. Let's see. This is C2. I run it on my Mac. You will see later. This is a dashboard. I write in a quick interface. Now I'm going to run the sensor. Okay, the sensor started. Next, I have switched to Windows 2008 to do some PowerShell remodeling. Windows 7 runs PowerShell v3, and in Windows 2008 PowerShell v2, I try to do some remodeling with enter PS session with Kerberos encrypted because it's inside domain, Windows domain. I use series of command, get host, get PS in, get process, and with some pipeline. Okay. Next, I've terminated the session, and then when I go back to the console, I'm going to pause here. You can see or notice that there is a hook happen after the session terminates. When the hook works, it hook into pre-exit process because I would like to do some real-time memory analysis. But the result of the memory analysis at this point depends on what is inside in the memory. Sometimes I got important clues. Sometimes I got nothing, it depends. Now back to the dashboard. You can see there's some log, sorry. Here you can see some commands, but not 100% because I just got some remnants of the memory at that time. If you enter PS session for long times, maybe you can get just only 30% because I just hook into exit process only. Next, I'm going to do some live demonstration. Okay. First, I'm going to run my HTTP server first because I put some malicious PowerShell script here. Then I'm going to run C2. Okay, C2 works. Going to Windows 8.1. This is a client. I will run the sensor. You can notice that it is run under administrator privilege. Back to Windows 2012. I'm going to use invoke command. Invoke command means that we want to run the command remotely on the target machine. I want to invoke the command to the computer name called Windows 8.1 with the command inside the bracelet. Here, I use IEX means that we want to download some script. That script is invoke mimicat.ps1 from this IP address, which is my Mac machine, and then run invoke mimicat. So let's see. Oh. Okay, so what about the demonstration? I'm not sure why there's a problem here. Just not sure about this. Because I have just only 5 minutes left, I'm going to show you some of my video demonstration. Instead, it's the same. Okay. This I start the sensor in Windows 8.1. Now I'm going back to Windows 2012 again, and then use invoke command. Invoke Mimicat try to locate some privileged account in plaintext. But as you know, if you run on Windows 2012 R2, you cannot see anything important. And it finished. Invoke command, then back to Windows 8.1 again. You can see there is some, sorry. Okay. There's a hooking and there's a capturing here. Capturing means that if there is some network downloading from the internet, from the network, it will capture something and it send to the C2. Now it finished hooking back to the dashboard again. Now you can see that there is a file that the PowerShell remoting from invoke command download from the network. It's a PowerShell script. If you use general protection mechanism, you cannot see this because it's encrypted. You need to do some real-time memory analysis only. And the last one is I show you some remote demonstration, but this one is local PowerShell at macro attack. I use the script from this URL. Let's see what it looks like. I start multi-handler to listen for interpreter to call back. Now going back to Windows 7, imagine that this is a user try to open some macro, enable macro, and then everything seems to be okay, and then back to Kali. They got interpreter back. This macro use malicious PowerShell inside. Now back to our dashboard. Yeah, you can see that there's a complete PowerShell call from that macro. The final thing that I would like to remind you is PowerShell is not PowerShell.exe or it's not PowerShell isc.exe. These two just only the host application inside your Windows system. If the attacker can write .NET application themselves, they can create malware that directly access to the .NET object, class, instance, and change everything inside your Windows environment, which my prototype cannot detect it at all. But if you think in another way, if they can run .NET application in your machine, they don't need to use PowerShell. They can do anything, right? And Yes, it's just host application. This is the limitation of my work. There are several work talking about Windows host application. You can learn from this list. And last but not least is the PowerShell v5. This is a greatly improved from the v2, v3, and v4 because there is a feature called anti-malware scan interface. This is very nice because if you remember that I tried to intercept some Windows 32 API, but this time some guys from Microsoft provide open API to you, and this API you can call, which if antivirus company can use this, it can locate or find any evidence that can identify which is malicious, which is not from hooking. So lots of offensive PowerShell modules doesn't work on PowerShell v5 in Windows 10 right now. And if you have any questions, just ask me here. Or if you would like to talk much about the platform, I'm going to allow here for tomorrow. And I'm really thank you for attending the last session for today. Thank you very much.